Have you ever stopped to wonder why soda cans are shaped the way they are? They're round, smooth, and easy to hold, but they're definitely not perfect spheres. At first glance, a sphere might seem like the obvious choice. After all, bubbles are spherical, planets are nearly spherical, and engineers know that spheres are incredibly strong when it comes to holding pressure. So why aren't soft drinks sold in little metal balls instead of cylinders? The answer turns out to be a fascinating mix of physics, engineering, manufacturing, transportation, and even the way we use our hands. The humble soda can is the result of decades of refinement, where every curve and dimension serves a practical purpose. Today, we're exploring why soda cans aren't perfect spheres, right here, on History of Simple Things. Imagine trying to package millions of perfectly spherical cans. A sphere holds a lot of liquid relative to its surface area, which actually saves material. However, it also wastes a tremendous amount of space when placed next to other spheres. No matter how carefully you arrange them, spheres always leave empty gaps between them. Those empty spaces become a major issue during shipping. A truck carrying cylindrical cans can be packed tightly with very little unused space. The cans sit side by side in neat rows, allowing manufacturers to transport as many drinks as possible in each shipment. Replace every can with a sphere, and suddenly a significant portion of the truck is filled with nothing but air. That means fewer drinks per shipment, higher transportation costs, more storage space, and ultimately higher prices for consumers. Even though a sphere is efficient by itself, it's surprisingly inefficient when you're trying to move millions of them around the world. Another problem becomes obvious the moment you set a sphere down. It rolls. The flat top and bottom of a traditional can solve all of these problems instantly. A soda can stays exactly where you leave it. That simple stability makes life far more convenient for consumers and factories alike. Modern beverage factories produce astonishing numbers of cans every minute. The manufacturing process begins with a flat aluminum disc called a blank. This disc is stretched and drawn into a cylindrical shape through several forming stages. Machines then thin the walls, trim the top, wash the can, print the graphics, and finally attach the lid after filling. Every one of these steps has been perfected for cylindrical containers. Creating a perfect sphere would require a far more complicated manufacturing process. Think about a supermarket shelf. Cylindrical cans stacked neatly in boxes, on pallets, and inside vending machines. Warehouses are designed around rectangular storage spaces. Trucks, shipping containers, refrigerators, and store shelves all have flat surfaces. A cylindrical can fits comfortably into these systems. Spheres don't. Boxes holding spherical containers would either need individual compartments to prevent rolling, or they'd require extra packaging material to keep everything in place. Both options increase costs while adding unnecessary waste. It's another example of how the can isn't designed in isolation. It has to work within an entire global distribution system. Our hands also play an important role. A standard soda can is easy to grip with one hand. Its diameter has been carefully chosen so that most adults can comfortably wrap their fingers around it. A sphere containing the same amount of soda would be much wider. Instead of gripping it naturally from the sides, you'd have to cradle it awkwardly. Drinking would become less comfortable, especially for children or people with smaller hands. The cylindrical shape also gives you a consistent place to hold the container while leaving the opening at the very top. It's a design that feels so natural, we rarely stop to appreciate it. Consider what happens when you take a sip. With a cylindrical can, the opening stays at the highest point as you tilt it. The liquid flows predictably toward the opening while air enters smoothly to replace it. Engineers don't just think about storing the drink, they think about the entire drinking experience from the first sip to the last drop. If you've looked closely at a soda can, you may notice something interesting. Although the body is cylindrical, the top and bottom aren't perfectly flat. Instead, they're gently curved. That's because flat metal under pressure tends to flex. The slightly domed ends strengthen the can without requiring thicker aluminum. The bottom in particular has a distinctive inward dome. This shape helps distribute pressure while allowing the can to withstand stacking forces during transportation. So, even though the entire container isn't spherical, engineers still borrow one of the sphere's greatest advantages. Curved surfaces are naturally stronger than flat ones. Rather than making the whole container into a sphere, they incorporated just enough curvature where it provides the greatest benefit. One of the biggest achievements in soda can engineering is how little aluminum modern cans use. Over the decades, manufacturers have continuously reduced the thickness of the metal while maintaining strength. Today's aluminum cans are remarkably lightweight, yet they safely contain pressurized beverages, survive shipping, and support the weight of stacked pallets. The familiar cylindrical design makes this balance possible. Because every part of the can has been optimized, manufacturers can use less metal without sacrificing performance. A completely different shape would require redesigning nearly every aspect of production. And there's no guarantee it would actually save money once manufacturing and shipping are considered together. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.